Ever try to make a game look realistic and it just falls flat? We're talking textures, lighting, that extra oomph.
Yeah.
Well, today we're diving into the Unity 5.x Shaders and Effects Cookbook to unlock the secrets of shaders.
Okay.
There's like the magic sauce behind stunning visuals.
It's true. It's like the difference between, say, a plain white cube and like a weathered, moss-covered stone.
Yeah.
Same shape, but completely different feel.
Okay, so shaders. It's code, right?
Yeah.
But what are they actually doing in our games?
Imagine you're painting a portrait. You've got your canvas, your paints, but it's the way the light hits the brushstrokes that brings it to life, right?
Right.
Shaders are like those brushstrokes. They're telling the game engine how light should interact with the surfaces.
So instead of just slapping on a flat texture, we're mimicking how light behaves on different materials?
Exactly, and that's how you get it. Metal that gleams, water that shimmers, even skin that looks realistically bumpy.
And this cookbook idea is brilliant. It's like, I want my game world to have glowing mushrooms. Recipe number 17.
Yeah, it's a great analogy. This book breaks down complex shader concepts into, digestible, practical recipes you can use in your projects.
I love that. Speaking of practical, this book is all about Unity 5, and they made this big deal about physically based rendering, or PBR. Sounds kind of intense.
It's actually about making your life easier. Before PBR, you had to kind of hack the lighting system to get things looking somewhat realistic. But with PBR, the game engine understands the physics of light in a much more sophisticated way.
So PBR is like teaching the game engine to see light the way we do in the real world?
You got it. It means less time fiddling with settings and more time focusing on the artistic side of things.
That's music to my ears. And the book talks about two main PBR setups, metallic and specular.
Uh-huh.
What's the difference? Is one better than the other?
Think of it this way. Building a sleek, futuristic spaceship. Metallic is your go-to.
Yeah.
It'll give you amazing control over how that metal reflects light, making it look, super polished or rough and battle-scarred.
And specular is for everything else.
Exactly. It's more about that general sheen you see on things like plastic, wood, or even skin. It's about finding the right tool for the job.
Okay, so if my game's going for a hyper-realistic look, PBR is the way to go.
Absolutely.
Yeah.
It's the industry standard now, and for good reason.
So we've got these shaders, they're doing their magic, but how do they actually get onto our 3D models?
That's where texture mapping comes in. And it's more than just slapping an image on a surface. Think of it like wrapping a present. You have to make sure the paper, your texture, lines up perfectly with the box, your 3D model.
Okay, so we're not just talking about color, we're talking about how that color is positioned and wrapped around the object.
Exactly. And the process of wrapping that texture is called UV mapping.
Right.
It ensures that, details like wood grain or scratches on metal appear in the right places.
And the book mentions this wild technique of packing multiple grayscale images into one texture. How does that work?
Think of it like those optical illusions where you see a hidden image if you look at it just right.
Okay.
We're essentially hiding extra data within the color channels of a single image.
Wait, so we're sneaking in extra information without the player even realizing it?
Exactly. This is super useful for saving memory and making your game run smoother, which is especially crucial for mobile games.
That is incredibly clever. It's amazing how much optimization goes into making games look so good.
It's a constant balancing act, for
Yeah.
sure. Especially when you start adding details like, say, normal maps.
Right. We've got color, we've got
Okay.
texture. But how do we make things look bumpy or rough without creating a zillion polygons?
Yeah.
Like if my game character had to have a separate polygon for every wrinkle, my computer would explode.
And that's where normal mapping comes to the rescue. Instead of actually building all those tiny details into the 3D model, we use a special texture, a normal map, to trick the eye into seeing them.
So it's like creating the illusion of depth and texture.
Precisely. It's what makes surfaces look weathered and realistic, or characters look like they have pores and wrinkles, all without tanking your game's performance.
That is seriously cool. So I could have a brick wall that looks super detailed and realistic, but it's actually just a flat plane with a clever texture on it.
You got it. It's all about working smarter, not harder, and normal maps are a prime example of that.
Okay, my mind is officially blown by the power of normal maps. It's like visual trickery, but in a good way.
It's one of those techniques that revolutionized game graphics. But you know what? We can take this even further. What if instead of just like faking details, we could actually change the shape of our models in real time using shaders?
Wait, what? We can do that? Like make things morph and warp without touching the original model?
Absolutely. That's the power of vertex functions. Think of it like this. Every single point on a 3D model is defined by code, right?
Right.
Vertex functions let us write instructions to move those points around based on all sorts of factors.
So if I wanted to create, say, like a pulsating alien blob, I could do that just by manipulating those points with code.
Exactly. Or imagine a flag waving in the wind.
Okay.
Instead of creating a complex animation, you can use vertex functions to simulate the way that fabric reacts to, forces in the game world.
That's incredible. It seems like it would be super complex to code, though, right?
It definitely can be, but the payoff is huge. And the book provides some great starting points, like creating a snow accumulation effect where the snow piles up realistically on surfaces.
Okay, vertex functions are officially going on my list of things to geek out over.
It's a rabbit hole worth going down for sure.
So we've covered how to make things look bumpy, shiny, even how to make them move in cool ways. But what about those extra visual flourishes? I'm talking about those cool screen effects that give games like a unique style.
Ah, yes. Screen effects are like the spice rack of game development.
Right.
They can take an already good-looking scene and make it truly pop. And Unity makes it surprisingly easy to create your own using shaders.
Okay, now I'm really intrigued. How does it work? Is it like adding filters in Photoshop, but for my whole game?
You got it. We essentially take the rendered image of the game, treat it like a texture, and then apply a shader to manipulate the colors and pixels.
So we're basically adding another layer of visual magic on top of everything else.
Exactly. Want to create a dream sequence with a hazy, ethereal look? There's a shader for that. Want to simulate the look of an old, grainy film? There's a shader for that, too.
This is amazing. Okay, hit me with some examples. What are some cool screen effects we can create?
One classic is the vignette effect. You've probably seen it in movies. The edges of the screen are slightly darkened to draw your eye to the center.
Oh, yeah.
It's very subtle, but super effective at creating a more cinematic feel.
Ooh, I love that. It's like adding a touch of Hollywood to your game.
Exactly. And then there's chromatic aberration, which creates a kind of trippy effect where the colors at the edges of the screen are slightly shifted.
Oh, yeah. That's often used for things like flashbacks or dream sequences, right?
Right.
It's like you're looking through a warped lens.
Exactly. And it's
Okay.
all done by manipulating the red, green, and blue color channels of the rendered image.
This is blowing my mind. Who knew you could do so much with just a few lines of code?
It's a testament to the power and flexibility of shaders. And we haven't even scratched the surface of what's possible.
Okay, so far, this deep dive has taken us from basic textures to mind-bending screen effects. It seems like shaders can do just about anything.
Yeah.
But before we get too carried away, there's one more practical question I have. How do we make sure our shader code doesn't become like a tangled mess as our games get more complex?
That's a great question. Because just like with any kind of coding, organization is key. And luckily, Unity provides a tool for that. CgInclude files.
CgInclude files. Those sound intriguing.
They're like building blocks for your shaders. Instead of cramming all your code into one giant file, you can create separate files for specific functions or effects.
Okay.
For example, you might have a file for your lighting calculations, another for your surface details, and so on.
So it's like breaking down a big, complicated recipe into smaller, more manageable steps.
Exactly. And then in your main shader file, you simply include those smaller files whenever you need them. This keeps your code clean, organized, and much easier to maintain, especially when you're working on, larger projects.
That makes so much sense. I can definitely see how that would be helpful. So CgInclude files.check.
It's all about working smarter, not harder. And speaking of smart, let's talk about some of the truly ingenious techniques you can achieve with shaders. Remember how we talked about how performance heavy it would be to model every single hair on a furry creature?
Oh, yeah. It would be like trying to render a million tiny cylinders.
Yeah.
A core computer wouldn't stand a chance.
Exactly. But with shaders, we can create the illusion of fur using a clever technique called multiple shader passes.
Multiple passes. I'm intrigued. Tell me more.
Imagine you're trying to paint a fluffy cloud. You wouldn't just use one solid brushstroke, right? You'd layer on multiple, slightly transparent strokes to create that sense of depth and softness.
Yeah.
That's essentially what we're doing with shaders.
So instead of rendering each hair individually, we're creating the impression of fur by layering these semi-transparent shells.
Precisely. And by carefully controlling the transparency, lighting, and even the direction of each layer, we can create incredibly realistic fur that moves and reacts to light, just like the real thing.
Wow, that's incredible. It's like creating a visual masterpiece, but with code.
It really is. And the book even covers how to add details like wind effects and gravity so that fur behaves realistically.
This is making me want to go back and look at all my favorite games with a whole new perspective. Like, how did they make that monster's fur look so real? Now I know.
It's amazing, isn't it? It's easy to forget that all these incredible visuals are essentially just clever manipulations of light and code.
And speaking of clever manipulations, there's this other shader example in the book that caught my eye. Heat maps. You know those visual representations of data where hotter colors mean more activity? Heat maps in games. That sounds kind of niche, but also really cool.
It's more common than you might think. Imagine you're designing a strategy game, right?
Okay.
Wouldn't it be awesome if the player could quickly see where enemy units are concentrated? Or maybe in a sports game, showing where on the field a soccer player spends most of their time.
Okay, yeah, now I'm picturing it. That's way more intuitive than just like looking at a bunch of numbers.
Exactly. And shaders are perfect for this because they can take that raw data positions, values, whatever it might be, and translate it into a visual representation that makes sense at a glance.
So it's like we're taking those like boring spreadsheets and turning them into a hit map that's actually part of the game world.
Precisely. And the book outlines a really elegant way to create heat maps using something called arrays in shaders.
Arrays. Okay, that sounds a little intimidating.
Don't worry, it's not as scary as it sounds.
Oh.
Think of an array like a shopping list. Each item on the list has certain properties.
Yeah.
What it is, how many you need, maybe even where to find it in the store.
Okay.
I think I'm following.
So how does that translate to like a heat map?
In this case, each item on the list represents a point on the heat map. Each point has a position, a radius, how far its influence spreads, and an intensity, basically how hot it is.
So the hotter the color on the heat map, the higher the intensity at that point. Exactly. The shader looks at all those points and their properties, and then using a ramp texture, similar to what we talked about earlier, it colors the screen accordingly.
That is seriously cool. It's like shaders are this secret language for visualizing data in a way that's both like informative and visually stunning.
You've hit the nail on the head, and what's so exciting is that we've only scratched the surface of what shaders can do. We haven't even touched on things like volumetric lighting, where light rays seem to scatter realistically through fog or smoke.
Or those amazing particle effects that make explosions look so epic.
Exactly. The possibilities are practically endless.
This whole deep dive has been a serious eye-opener. It's like you've unlocked this secret level of game development for me.
It's been my pleasure to guide you through it. And honestly, the most rewarding part is knowing that you're now equipped with the knowledge to go out there and create your own amazing visual experiences.
I can't wait to dive into this cookbook and start experimenting. Who knows what kind of visual magic I'll be able to conjure up with the power of shaders.
That's the spirit. Remember, the only limit is your imagination.
This has been an awesome deep dive into the world of Unity shaders. A huge thanks to our expert for joining us today and sharing their insights.
Anytime. Happy coding.
And to all you listeners out there, keep experimenting, keep creating, and we'll see you in the next deep dive.